Today we're talking about an exciting and underrated tool, and that is the UnrealReader plugin from the Foundry. With the 13.2 version of Nuke, the UnrealReader comes built in, and integration with Unreal Engine 5 is now supported, and it works like a charm. Now, full disclosure, Foundry did provide me with a Nuke license to make this video, but I'm not being paid to promote this. They have no say in what I talk about in this video. No money changed hands. This video does have a sponsor though, and that is CG Spectrum. Now, what is UnrealReader? And more importantly, for those unaware, what the heck is Nuke? Nuke is the industry standard for compositing, so if you're doing any kind of serious comp work in VFX, chances are you're going to be using Nuke at some point. Under the hood, the UnrealReader node connects Nuke to Unreal's movie render queue using the Nuke Server plugin over a TCP IP connection. UnrealReader makes it quick and easy for you to generate live renders from movie render queue, change the render settings, control the results in Nuke by breaking down your renders into layers, render passes, even tweaking shot framing by overriding the Unreal camera. Overall, it is amazing to have this, and if you haven't been using this yet, you really should. Now, a few good things to know about. As of Nuke 13.2, the following versions of Nuke are supported with the UnrealReader. We've got Nuke X, Nuke Studio, Nuke Indie, and Nuke Non-Commercial, which means that you can test out the UnrealReader for free. The standard, regular version of Nuke doesn't support UnrealReader in terms of altering the existing render data, but it can pull through renders with existing settings or loading existing Nuke scripts with the UnrealReader node in them. Nuke Server is currently available on Windows for Unreal Engine 5, with a Mac OS version coming soon, and for those of you interested in a Linux version, you can request a dev build through their support, which I'll include a link to down below. I'm also going to include an FAQ just because there's a few good bits of information that you might want to know about. So let's jump right into how to get all of this set up right after a message from my sponsor. A big thank you to CG Spectrum for sponsoring this video. CG Spectrum is a global, top-ranked training provider offering specialized online courses in real-time 3D, game development, animation, VFX, and digital painting. They're an Unreal Authorized Training Center and Unreal Academic Partner, and their courses include personalized mentorship from industry professionals. I mentor at CG Spectrum myself part-time and help develop their real-time 3D, technical art, and virtual production course. Right here is an example from one of my students. So if you want to learn Unreal Engine with an industry mentor guiding you, check out the link below or visit cgspectrum.com for more info. You'll get the most practical and up-to-date knowledge along with the skills, connection, and industry awareness that film and video game studios are hiring for. Thanks again to CG Spectrum for sponsoring this video, and with that done, let's talk about how to get the UnrealReader set up. Now, before we do anything in Unreal or Nuke, the first thing we need to do is download the Nuke Server plugin that you can find in the link below. You can't find this plugin on the Epic Marketplace because it is a custom plugin built by Foundry. When you get to this page here, scroll down all the way to the bottom, and you're going to see we've got Nuke 13.2 or 13.1, and download the plugin for the Unreal Engine version that you're using. So in my case, I'll be using Unreal Engine 5 on Windows, so go ahead and download that. Once you've unzipped the file, you're going to find a Foundry folder in there, and we need to copy that folder into the plugins folder of your Unreal Engine install. By default, for most people, it's going to be found in C, Program Files, Epic Games, and in my case, I'm going to go to the UE 5.0 folder, go to Engine, Plugins, and you can copy paste the Foundry folder directly into the plugins folder right here. You'll see I already have the Foundry folder copied there. Go ahead and do that. Once you've done this, go ahead and start Unreal, and we'll now be able to enable that plugin. So now with UE5 open, I'm going to go to the Settings button up top here, go to Plugins, and in the search panel up top here, we're going to search for Nuke. And if you copied the folder correctly into your plugins folder, you should have the Nuke Server plugin show up here. Make sure that's enabled. You'll have to restart the engine, and then we'll be ready to go. I'm going to close this, and now there's one last thing we need to do before we can jump right into Nuke. So with the engine restarted, we can now click on the Window button up top here, and now you should have a Nuke Server option show up right here. Click on this, and you'll get a new window popping up. The port number by default, I believe is 9,000. The number you use in Unreal doesn't really matter. What is important is that the number you use in Nuke later matches this number. So for now, just leave it at default, hit the Start Server button, and when the server status says running, we're now ready to jump into Nuke for the first time. So now I have Nuke X open, but the plugin also works with Nuke Studio, Nuke Non-Commercial, and Nuke Indie as well. No problems. So the first thing we need to do is we're going to click in the viewer section down here, press the tab key, and search for UnrealReader. Click on this, and you'll have a new node showing up right here. And now you'll see up on the top right-hand corner here, we've got port 9000, which is usually the default. For me in Unreal, it was set to 4500, and I'm going to hit connect to server. And now, if you've done everything correctly, you should have the Unreal Engine version right here. Fetch latest shows up. UnrealReader and Nuke is now connected with Unreal Engine directly. But maybe you don't see anything. The screen is still black. There's one thing we need to do if you're not familiar with how Nuke works. So we're going to select our UnrealReader node right here and press the 1 key. And basically, pressing the 1 key has connected our UnrealReader node to the viewer. You'll see we have a little 1 key here. If I had something like a grade node, for example, and I press the 2 key, you'll see the viewer is now showing the grade node. Of course, there's nothing there, so that's normal, but you get the idea. A toggle between 1 and 2, that's how you can tell the viewer what to show. This is going to be important for later. So with the UnrealReader node loaded, you'll see here we have the project path where we can designate which project is being loaded. We can choose the map that we want to load and the sequence as well. So for example, if I have another sequence I want to load instead, I can click here and choose this one, for example, and it's going to update automatically. So this is, for example, just another shot that I had where the camera is panning and we have some motion blurred elements here. It's really cool and very easy to switch between levels and sequences directly within the UnrealReader. It's going to update live in front of you. Next, we can choose the scene unit, the render mode, and the render mode is basically if you want to designate whether or not you want to use stencil layers. And if you don't know how to use stencil layers, I have a video about that right up here, so go check that out if you need it. In image format is where we choose the image resolution of our shot. So in my case, I want to render this as UHD 4K. As you can see, it's going to update automatically for you. Next, we have overscan right here. If you need to work with lens distortions and stuff, overscan is a fantastic way to do that. We've got the frame range of our sequence automatically being updated right here, so you don't need to manually put that in. Next, at the bottom here, we have the write section, and we're going to get into that a little bit later because UnrealReader is not actually writing anything to disk. UnrealReader is streaming data directly from the movie render queue under the hood. So at some point after adjusting all of your render settings, you're going to want to write this render to disk, right? You're going to want to write those frames, but we're going to get into that a little bit later. Feel free to use the chapters down below to skip to the appropriate part of the video. Now, before we carry on here, let's address one of the glaring issues that we have here, and that is color. You'll see the colors here are kind of washed out and flat and oversaturated and looks frankly terrible. Taking a look at this screenshot from Unreal right here, that's what we should be getting, but this is what we see in Nuke instead. And for those of you who have watched my color grading tutorial in DaVinci Resolve, again, you can watch that video right here if you haven't already, you're going to know why Nuke is looking this way. And the reason for that is Colorspace. Nuke is expecting a linear image, but by default, Unreal does not spit out a linear render. So the first thing we need to do is go to the Advanced tab of the UnrealReader, and right here in Color Output, we need to disable the tone curve. By disabling the tone curve, it's going to send Nuke a linear image. So I'm going to click that here, and you'll see things already look a whole lot better. If I toggle this back and forth, before and after, it is a whole lot better, but the colors are still off. And in this specific shot, I actually do like how oversaturated and the tonality of the colors. I think this actually works very well for this shot, but it doesn't match what we have in Unreal. And the reason for that is because Nuke thinks that this render is in aces, but it's not. It's a linear sRGB image. So we just need to tell Nuke how to interpret that. And the way to do that is we're going to select our UnrealReader node here, press the Tab key, and we're going to search for OCIO Colorspace. And we're going to double click on the OCIO Colorspace node, go to Input, Color Spaces, Utility, Utility Linear sRGB. And now your render should match pretty much what you have in Unreal. And that is how you address those glaring color space issues right here. If this was a read node, we could just directly put in the input transforms of the read node, but again, we're going to get into that a little bit later. So going back to our UnrealReader node, I'm going to go through all of the settings with you, and as we go along, I'm going to show you some of the render settings that I use for my own renders in 95% of cases. So let's do that right now. And starting off with the Render tab up top here, this here is quite possibly the best part of the UnrealReader node. As you'll see here, we have all of our render passes in one nice clean list. For those of you who are familiar with the movie Render Queue, you'll know that using render passes is a little bit unintuitive, and sometimes it's hard to find them, or sometimes they don't show up at all. So thank you to the team at the Foundry for coming up with this solution, because now we have all of our render passes here and a wonderful description of what all of those render passes do. So in my case, I'm going to turn on Cryptomat, World Depth, World Normal, and maybe World Position as well. Alright, so Future Will here, chiming in just because there is one really cool feature I forgot to talk about in the initial recording, and that's showing off the Preview Layers feature. So going back to my UnrealReader tab here, I'm going to set the render mode to Stencil Layers, and bear with me here. With that done, going back to the Render tab here, I'm going to click on Preview Layers, and now this is going to preview our object IDs. And now by clicking the Pick or Add button right here, I can hold the Control-Shift key and click to select individual objects in my scene and create my own mask that way. If you hold Control-Shift and drag, you can select multiple objects like this, and they all show up in the layer list right here, which is absolutely awesome. I can click the Pick or Remove button here, Control-Shift drag to remove objects from my selection, like so. Also, by going back and setting the render mode back to full image, once you have your render passes set up here, you can visualize them by going to the RGB button over here, and you'll see we got World Depth, World Normal, World Position. By clicking on one of them, you should get your render passes showing up like so. If for whatever reason your render passes don't show up here, you can click on the Update Channel List button right here, or in the UnrealReader tab, click on Fetch Latest. Once you do that, you should have all of the render passes you chose show up in the list here. And with that said, let's get back to the original recording. Now going to the Advanced tab here, this is probably something you're going to be very familiar with if you've been using the movie Render Queue. So we've got the Deferred Rendering tab. In the Cryptomat, we determine which object IDs we want. Do you want the material, the actors, so on and so forth. The anti-aliasing sample, again, if you watch my movie Render Queue tutorial right here, you'll find I do a deep dive into which settings to use here. Now for my own sake, I usually set this to 16, and with the anti-aliasing method set to none. 16 temporal subsamples will give you a much cleaner motion blur, much better results, much better edges along your models, and 16 is usually more than enough. Sometimes I need to bump it up to 32, but it's rare. For those of you who are using Lumen, you might want to increase the render warm-up count and the engine warm-up count to something like 30 or 50, because as you're probably aware, Lumen needs a few frames to kind of settle down a little bit. So if you've rendered a shot here and you notice that there is no GI, there's no global illumination, no indirect illumination, it's probably because you don't have any render warm-up frames. So increase both the render and engine warm-up frames if you run into any issues with Lumen. Next, we got the shutter timing, color output, and the rest of these at the bottom, game overrides, high resolution. I never really touch these, I just leave it at default. If you want to disable motion blur entirely, we can click the Disable Motion Blur button right here. And next, let's go to the Camera tab over here. And this is where things get really interesting. So what I'm going to do now is I'm going to click the Link Output button here, click on Create Camera, and you'll see we now have a new camera node selected right here. So if I select this and press the 1 key, you'll see now we are kind of in a 3D world space type of thing. And if I zoom out, you'll see we now have a camera here. And if I scrub through the timeline here like this, you'll see this camera is actually hooked up with the camera animation that I have in Unreal in my sequence. So I animated the camera in Unreal, and UnrealReader is able to read that camera data and bring it into Nuke in a 3D space. Now, I'm not an advanced compositor, but I can tell you that having access to the actual camera that's being used in our renders is immensely powerful. It's amazing for any kind of 3D projections or any kind of matte painting work. There are hundreds of possibilities and reasons for using this, so it's absolutely awesome to have access to that data. Again, a big thank you to the team at the Foundry for coming up with this. This is so cool. But there's one more thing we can do with this, and it's pretty awesome. So I'm going to select this here. I'm going to delete that, and I'm going to create my own camera. And now we have a new camera 1. I'm going to grab this like that, move it up here, move it up in world space like this. And now I'm going to connect this to my UnrealReader node. I'm going to click on my UnrealReader node or OCIO node, press the 1 key, and you'll see the camera that we just created in Nuke is overriding the camera that we have in Unreal, which means that any compositor or anyone working in post-production can create their own camera and render straight from Unreal using that custom camera. So if a compositor needs to make some small changes to the camera or its position or any of its depth of field settings, they can do that right here. Probably a bit of a niche use case, but it's still very cool to know about because I'm sure someone out there wants to use this. So I'm going to delete this and revert back to my default one. So to be clear, when you delete the custom camera that you made, it's going to revert automatically to the camera that is in your Unreal Engine sequence. Going back to the UnrealReader node, the last tab up here is the Variables tab. And this is where we designate all of our console variables by clicking the Add button, entering your console variable, so r.screen percentage with the value of 200. For example, if you want to remove it, click on this and delete it. It's pretty straightforward, very self-explanatory. So the last thing we want to do is we want to be able to write our files to disk, right? So I'm going to go through this with you just because I know it's a little bit weird for those of you who are new to Nuke. So in order to write this render to disk, we're going to click on the little folder icon right here at the bottom of the UnrealReader node. I'm going to choose this folder here. And you'll see we have the file path, but you still need to tell Nuke what the name of your file is going to be because Nuke doesn't have a way to know that. So I'm going to call this render example _a _, and next we need to add some hashtags. I'm going to add 4 of them because the hashtags are what's going to designate the frame number. Okay, this is not going to be added automatically. So this is very important, otherwise your shots are not going to render. And lastly, we need to write .exr like this, because otherwise it's not going to write properly, even though we designated the file type here. So having the hashtags and the .exr at the end is the most important part of this write tool feature here. And we're going to click on write to disk right here. So when you click the write to disk button here, you'll see we have a new read node show up here, but it says error sometimes. Don't worry, the reason for that is because when you do that, Unreal has to actually render your frames, so it can take a while. And depending on the complexity of your shot, the duration of your shot, and your render settings, it can take anywhere between a few seconds and several hours to render. So A, just wait a little bit, and B, just go ahead, double click your read node, and click on the folder icon here, and pick the correct render in the list. So right here is render example A, just like that. And with the read node selected here, we're going to press the 1 key, and then we now have our render. I'm just going to select my UnrealReader here and press the D key to disable it because I don't want this running in the background right now. So now, with our read node selected, we can scrub through the timeline and see our camera animation just fine. But of course, the colors are wrong, so you can either use the same OCIO Colorspace trick that we used earlier, or by double-clicking on the read node, we can go to the input transform go to Color Spaces, Utility, Utility Linear sRGB. And now our render should match what we have in Unreal, just because we're telling Nuke in the input transform how to interpret this render. And if I wanted to visualize my object IDs, press the Tab button, search for Cryptomat, plug this into my read node here, press the 1 key in my Cryptomat node, and you'll see we now have all of our object IDs right there. Of course, this is going to depend on your Unreal Reader node settings in the Advanced tab by ID type. So depending on what you rendered, this is going to change that. So guys, I know this was a lot of information to take in, but I hope you're starting to see the power and how useful the Unreal Reader node is for post-production. How are you going to be using it? What are some features that you would like to see implemented in the Unreal Reader? Let me know in the comments down below. So guys, I hope you found this video helpful. If you did, do consider subscribing and giving it the old thumbs up. Thanks so much for watching, and as always, happy rendering.